Oh, hello there. Let's get on with today's lesson about finding a quadratic from its graph. So if you're given the graph, look at the key features that you can see there. You've got x-intercepts and a y-intercept, or in this case it's just another point. So identify what your x-intercepts are. We've got our x-intercepts of -1 and 3. Now we're going to use the general equation for a quadratic when it's in the form with x-intercepts. So in this case we would have our factors of x plus 1 and x take 3, but you must account for the dilation factor if you like, and you always need to put in that a, and that's what we now need to solve. So to find that unknown we need to use some other fact, and that's where this other point comes in handy. I find it useful to write that point as coordinates, so we're going to sub in that point, which is 0, 3. Now something that is worth noting is the shape that we've got here called concave or concave down. And what value would that tell us for A here? I guess you could think of it as a sad face, and sad faces are negative as opposed to being positive and happy. So you're therefore expecting your A value to be less than 0. So that'll help you know if you've got the right answer or not. So substituting that number in here, so this 0, 3, where you see an x, you're putting a 0, and where you're seeing a y, you're putting a 3. So this comes out to be this 3 there. Now, just out of interest, I've swapped these around. I've put this on the left because I like to have the thing that I'm solving for A being on the left, and therefore that y is on the right, but it really doesn't matter which way around you do that. And you'd work out here that A is equal to -1. And that confirms what you're expecting, that A should be less than 1. So our final equation for this graph is y equals negative x plus 1, x take 3. You can put it as a 1 here or just leave it as the negative. So that's that one. Next. So thinking about this, x-intercepts. Well, there is one, but it's repeated and it's a touch. And so hopefully you remember that the type of factors that you've got there is a repeated factor. So write down your x-intercepts. X-intercept in this case is just 2, and it's worth noting that that's a touch. Also, what A value have you got here? We've got a positive shape, a smiley face if you like, so therefore that's going to be greater than 0. Write our general formula for a quadratic, this time putting it in the form with a squared factor, and noting the sign here, it's x subtract 2. And now you use the other piece of information, that point there, to help you solve for A. So I'm going to write that we're going to sub in that point, 0, 8. So where you see an x, you're putting a 0. And therefore, where you're seeing a y, you're putting in that 8 number and solving for A to get A is equal to 2. But don't leave it there. Answer the whole question. What is the equation? It's y is equal to 2, bracket x take 2, all squared. Now, you can always check any of these on your calculator to confirm that. So you would graph that, and then you could find a couple of points and see if it matches the picture that you've got there, just to confirm that you're on the right track. All right, a few more. What if it's in this shape, but instead of having all the x-intercepts, we've been given this axis of symmetry? Now, a point to remember is that the axis of symmetry is halfway between both x-intercepts. So thinking about the distance between this -2 and the axis of symmetry of 1, how many steps is it, if you like? 3 steps. So therefore, how many steps must it be to the next x-intercept? Whoops, another 3, which makes the x-intercept 4. So let's write down some facts that we've got here. We've got the x-intercepts of -2 and 4, and an axis of symmetry of x is equal to 1. So because you've got the two x-intercepts, use the form with linear factors. So you have the coefficient a out there because we don't know that yet, putting in the two x-intercepts, noting the sign change, and now we need to solve for a. So there'll always be a second piece of information that you need to use to help you solve for that. So we're going to sub in that point, because it's a y-intercept, the x value is 0, and solve for a. what a value are we expecting here? Looking at the shape, because it's concave down, we're expecting a to be less than 0. That's a 0. And subbing that in, we get that this is all equal to 16. Solving for a, you get -2. So our final equation is y is equal to -2, and that -2 is what we expected, a negative value for a, and then with the two linear factors there, which match the x-intercepts. Excellent. Now, what if you don't have a graph? What if you've just got words here? So we're asked to find the equation of the quadratic, so it's a quadratic, so power 2, whose graph cuts the x-axis at 4 and -3. If I were you, I write down facts as they come across to me so that I know I've taken them into account. So I've got my two x-intercepts, and it passes through the point of 2, -20. So that's going to come in handy. And the extra step here is we must give it in expanded form. So it's the same technique now that we've been doing. You write out your general form of a quadratic with the a factor there, your two linear factors, and you put in your x-intercepts with the sign change. And now we've got this unknown of a, so we need to solve that by substituting in a point and solving for a. So this time around x is not 0. Zeros are always handy because everything else cancels out. We've got 2 take 4 and 2 add 3, and that whole thing is equal to -20. Working out each bracket there, we've got a bracket -2 bracket 5 is equal to -20. This part works out to be -10. So dividing over here, that's -20 divided by -10 gives us 2. Writing this in the form now, where we substitute in the a, but we're not finished there because it wanted it in expanded form. So I'm going to expand the brackets first. What have we got? X squared plus 3x take 4x take 12. I'm going to do a bit of tidying up all in one go. That this becomes -x, but when you multiply it by 2, you get -2x, and at the beginning 2x squared, and don't forget -24 on the end. So check that we've answered the question. Yes, we've given it in that form, and that's our answer. You can always graph that on your calculator and see if it goes through that point and if it's got those x-intercepts. The last two here, finding the equation again from the graph, but this time you don't have the x-intercepts, you've got a vertex. So that's going to be helpful as a point. So the other general form that you can use for a quadratic is in the turning point form, which is, well, let's identify what we've got first. We've got our vertex here, and our a, what are we heading towards? Greater than 0 or less than 0? I hope you'd say greater than 0. Now, our general form for turning point form, so we've got the factor here of x, but it's squared there. And now you look at these two values here. So the 3 is the x value, but just like x-intercepts with the sign change, so it's x subtract 3. And then this -2 is the number that goes over here. So that's the general form in turning point form. And that, as you can see, these numbers are formed from the vertex. But we still don't know what a is, so we need to substitute in the other point, which is 0, 16, and solve. So we have a times by -3 all squared take 2 is equal to 16. So just a couple of extra steps of solving here, working out the square and adding 2 to both sides. We end up with a is 2. And therefore, putting that back in, the 2 is there, x take 3, all squared take 2. And you can always check that. And our last one is, again, turning point form. What a value might you be expecting here? Looking at the shape, because it's negative, you would expect less than 0. And we have our vertex. So we're going to use the vertex form again. We've got our a here. It's a squared factor with an x here. And then you look at the two values here. So the -4 sits with the x, but with the sign change. And the 2 from the vertex is the number added on the end. And when you did that by completing the square, you may remember, we need to solve for a though, so we're going to substitute in the other point. Now, that's in a different form. that negative 2, is that the x or the y value? It's the x. And what would the y value be? Well, because it's an x-intercept, it's actually 0. So don't be tricked by that one just because you've done it in a different way every other time. Substituting in for x and y and solving, so this comes to be 2 squared, which is 4, so 4a, moving that 2 over, so therefore a is equal to negative 1/2, and finishing that off with the equation x plus 4 all squared plus 2. There we go. Have you subscribed to the channel? Make sure you tell your friends. See you next time.